So we are learning the joys of troubleshooting SAS inside the virtual machine, but I've just learned some very useful things. So apparently, if you there is a place on campus, not on campus, when you're on the university network called the H drive, and you have to physically map it. If you store your SAS to be imported into SAS files there, it apparently works seamlessly. If you try to put it inside any personal folder that you have that's under your users, SAS can't access it, and it gives you a big red angry message about it. So I have never mapped the H drive either onto my PC, so we're going to do it together. Okay? So do you have your personal laptops?
Mine's broken.
Your whole laptop is broken?
Yeah.
Oh.
I dropped it.
Oh, shoot. That is a problem.
But someone's doing something to it, and hopefully it'll be back by maybe Friday. He said he doesn't know.
Okay.
He doesn't have any pink ones, pink parts and stuff. On a pink computer, and they were giving me pink ones in stock to fix it. I was like, okay.
So it'll be like blue and pink and green, and it'll be like rainbow.
Like another car.
Yeah, I was just thinking that, like the hubcaps are a different color or whatever. No worries. Well, you can access from any computer in this room or out.
Yeah.
Office hours will be out there today because I'm going to help everybody get to this if it's the last thing I do. Isn't it funny how, like, statistics is hard, but this is harder? Right? Like, technology is supposed to make our lives easy. So I asked the Google, Iowa map H drive, and this is what I found. So the first article appears to be what we need. If you are off campus, which we are not, all right, let's see. So I opened up an Explorer tab here and verified that on my PC I don't have an H drive, all I have is C. Okay. So under Drive Tools there should be Map. Let me see if I can find it. No, it's under Computer. I'm running Windows 10. Map Network Drive. Mac people, is there an analog that you follow? No, I don't know Macs. I'm like my mom when it comes to Macs. I can't help you. So.
The directions are in there.
Okay. Okay, great. So we found that same page.
Go back to that page. What was it called?
I just asked for Iowa map H drive, and this page came up as the first option. So let's follow these instructions and see if we can't get this stupid thing to work. All right.
I do.
Yeah, you don't. I don't know that you need to be on the VPN if you're on this network, but I'm not for sure.
But at home you will.
Yes, at home you will. Correct. All right. So here's what I have to type. Replace this with my HID. So I am mapping Map Network Drive. It's called H. So it's a place you can access from wherever. And replace Hawk ID with mine. Now what? Log in with your Hawk ID at UIowa or Iowa Hawk ID. All right. The or is confusing, but whatever. Where did it go?
I got that.
Okay.
You're going to be on Cisco right now. You're on campus. So you're involved in the weekend. Oh. No, you work. So this part.
All right, we'll see what happens. I win! I win! Here. I have an H. Okay, now I can help the rest of you. That's what that means. So put your homework in this place is the thing here. All right. So we're going to have an impromptu office hours tutorial on how to get SAS to be your friend this afternoon. If anyone would like to join us. You can't come? Okay. Well, the good news is that once we get enough people getting this correct, I can help troubleshoot errors. But it seems to be the case that SAS is not recognizing things that are not like general level drives. I've heard this before in other types of operating systems. So that's my theory.
The
Yeah.
thing you've highlighted, or that was highlighted?
Yeah, this
Did
right
you
here.
just put that in the search bar, or where did you put that?
I'll show you.
Okay.
Right here, copy that. Under your PC, under computer, there is an option for map network drive. You don't have that.
No, I just don't know where it is. I'm sure I have it.
Oh, what is it in Mac people? Where is it?
Mag was something else.
Okay.
The top menu bar, click go and click
Oh,
connect
go,
server.
here we go.
Yeah, I don't know where go is.
Okay, get out of there.
You have to be I don't know where go is either.
Go is if you get out of your internet stuff, it's right on top. I just found it accidentally.
Like you can't be in another program.
Correct. And then it'll open up and up beside you left go.
Oh, go.
Yeah, so
go.
Mac people need to find the go place.
Oh.
And then paste,
I
and
think what
then,
you copy and paste in there looks a little bit different from what the
Good
PC
saves.
was.
okay,
So,
okay,
What's that?
so, that was Windows instructions, that I found.
it looks just a teensy bit different. It has like
Yeah.
SMB. And then
It's
the go
that
thing
one.
is the same thing up there.
Yeah, so this
Yeah, those are the Mac directions.
Okay, so do that one instead.
Connect, okay.
Connect to server, do that, replace it with Hawk ID.
That's my password.
Yep, and it'll probably want your,
I need my computer password is messed up.
The Hawk ID's on top.
yeah, you'll probably have to re-enter a password to connect.
I had to change my Hawk ID and it logged me in.
Okay.
It wasn't my Hawk ID, it was like my first and last name, so I thought it was my computer.
So far, got H drive
I
and
probably.
It doesn't like this thing.
information.
Okay, so
Just
then in
sign it
theory,
like you would
were you able to pull out
I am.
things run it successfully?
Yeah.
Okay.
So I tried.
It sounds like this is like stuff you don't get access
I just kind of dragged it over here. So that when I
Yep.
It's
not letting me in.
So take your Hawk ID,
I might actually make this
email,
or
Hawk ID, and put it in the, like, as if it's an email.
Registered user.
yeah, like I just kind of did.
So,
How's this road doing?
I want to
Enter your name and password for the server.
Okay.
did you get that? Did you do the SVSM home?
Yeah.
And did you do your Hawk ID instead of Hawk ID?
Yes.
Okay, and so then, and that's, my Hawk ID is like Cambridge.
Well, it's my, so it should just name me Hawk ID.
Yeah, that's where my problem was. And then I used my Hawk ID,
Your password.
my password that I use like for my email. Which is where I was going with, that really hard to explain.
Yeah, so you
There we go. Now I don't know what this
Now,
means.
now.
Now I'm in this.
Where are you supposed to be here?
I don't know, now I don't know, so great, I'm in this server, but I don't know what this is. So maybe this home, so see on the left how it says locations, remote disk, home Iowa. I think that's where I'll probably save stuff.
Yeah, I think you're right, but what did you click when you got into here?
I didn't click anything.
You got right into that?
I was just popping around.
Oh, picture SAS, my SAS files. I have something called my SAS files.
In there?
In here.
Wait, so what do you do?
9.
That's when I get.
I don't know, I didn't click anything. This is, I don't know my videos, my SAS files. Download.
I do too.
You have my SAS files?
Yeah. Okay, so that's where I should save that stuff.
Is this our intro?
So this is our H.
That we have access to now if I click that go button.
This might be the H drive for like your connection of everything for Iowa.
I might need to take when I got computer
I don't know, like,
class before I take this class.
I don't know how to find my H drive.
I don't know where H drive is. I'm dead serious. I'm dead serious.
Desktop. Is this like my, what does that mean? Oh, nothing saved.
Okay, so I'm adding big news. I'm adding my desktop folders that have my SAS on them into the SAS file section. And it's there.
So, yeah, you want.
Do you have something, do you have a folder in your stats file?
Yeah, it's like 9.
What does that mean?
I don't know,
But how are you getting there? Okay. So we'll, how's this for?
Oh, so go back to where, go to go. We think you might have it.
No, well, we found our H drive.
Okay, that's the place to start, and you gotta put the files in there.
So the files,
Like how you log in.
so we have a SAS file folder. Is there something in there called a 9?
Oh, that is automatically created by the program.
Oh, okay, so we didn't do that.
Yeah.
So the homework assignment file, I've downloaded it.
Okay.
Do I drop it into that box, that folder then?
You don't have to put it inside SAS, you can make your own file structure, but yes, it needs to be in H.
But, okay, it needs to be in H, not necessarily in the SAS folder.
Right. Yep.
Would you like to try that again?
No, I'm saying.
Oh, I was going to say, would you like to try that again?
All right.
'Cause,
So we're working on it. Working on it. Let's see. So that's good because your first homework is due a week from yesterday. All I'm looking for you to be able to do is to pull up that example 2 syntax file, find the right parts of it, copy it into your homework, and figure out what to change to make it use the variables that are part of your homework. So there's nothing that I'm asking you to do that you don't already have a direct example of how to get it. Fair? To be fair, I had to ask the Google for a lot of these codes because I'm not as advanced in Stata as I am in SAS, and so I had to track down all that, but I think I've got it working. All right, so we also had a quiz for today. We can talk about those answers while folks are still trying to get into the SAS. We won't need SAS to be in class today. I'm just trying to make sure that everybody can get into it and figure out how to change that path to find your stuff. But we will have our group office hours out here to help too. Yes?
This quiz for today.
I'm sorry?
Was this quiz for today?
Yes.
And then the other one with the 12 questions.
The 12 questions?
The other one that's not in the icon, it's in the.
Oh, the homework. The homework is due a week from yesterday. Yeah. So yeah, the homework is, I always want to make sure that you have at least a week after we cover something before you're asked to do it on your own. So no worries, you can work on this with us if you'd like. So just to recall, the quizzes are formative assessments, as I'm told they should be called in the College of Education. Just to give you a chance to review and for us to make sure that the big picture stuff is there. So first question here, what's the difference between a mean and a standard deviation? A little bit of a softball. Who'd like to take a swing? Yeah. Hey, Lynn. Yes, got it. Okay. What will you say? Mm-hmm. What is the difference between a mean and a standard deviation? We'll start with the first part of it.
Average of all the data.
Mm-hmm.
And standard deviation shows how the data
Dispersed, yes. Yes, so there are two different ideas. Mean is central tendency, it's the most common measure of central tendency, and dispersion is covered by standard deviation. Standard deviation is the average distance from the mean for a given person in your sample. And then in terms of language, what symbols are usually traditionally used to denote each in a sample and a population?
So the sample is X bar for the mean, and for a population it's mu.
Yep, U-looking thing, yes. And how about for standard deviation?
Sigma
Sigma for which one?
for population,
Mhm.
standard deviation, and I think S.
Yep. By the way, that distinction is going to fall off the cliff real quick. When we get to models next week, people are going to use population notation all the time because that's always what we're trying to make an inference about. So this is going to not be relevant pretty soon. Also, something that you'll have to answer in your homework, what letter is used in reporting a mean in like an APA style report? Don't think too hard.
Mu?
M. Yeah, so you are allowed to abbreviate, such as in tables, M stands for mean. That's an accepted abbreviation. How about standard deviation?
ST.
ST. Yep. Yep. Good. Number 2.
So when it's
Funny?
M, do you mean like M, like regular M? Or
Regular
M like
M.
mu?
Mu is in if you're writing like an equation or referring to a parameter, but like in words, like regular letter M.
Detachable?
Yes, and usually italics too. Mm-hmm. To set it off, because that way it looks weird. There's just like a capital M sitting there. But if it's italics, it's like indication. Oh, this is a stand-in for something else. So funny? No, no, you're laughing.
It was the abbreviation.
Abbreviation.
STD.
Oh, STD. Yeah, it is not the same thing. Yes. Although in certain functions in programs, it is STD, actually. Or STDDEV sometimes, too. That one's a little more, but in papers, it's STD.
How do you write X bar? Because that took me forever to figure
Oh,
out how to
yeah.
write that.
Me too.
I'll show you.
Is it X bar or Y bar?
It depends. So notation is always sort of contextually specific. For me, X's are predictors and Y's are outcomes. And so, like, if you're estimating in a model, like it would be Y bar if that's what you're predicting. But it's 6 of one, half dozen of the other. Let me pull up a document here. So it's Alt and equals to get into the equation editor. And from there, I don't know the shortcut, but under this toolbar for equations, you're looking for the one that's accent. And then there's all kinds of choices. And there's a bar. So the only other one that you will see in statistics is a hat, a caret. Let me see if I can find that one. Boy, this print is small. Can't tell. But anyway, there it is. That's a caret. So. And then you just go into the little box and type it like that. And hit the arrow key to get out of it and to be able to keep typing. Otherwise, it'll keep extending the accent over whatever you've typed. Okay, good. All right, number 2. What 2 elements go into determining the standard error of a sample mean? So I told you didn't have to memorize formulas, but it's 1 over the square root of the other.
Sigma over the square root of the sample size.
Boom!
Mathiest thing I've ever said in my life.
And sample size, by the way, what letter?
Big N.
Big N.
Italicized.
Boom! Italicized. I like the
I'm getting quite cool over here.
indeed, quite cool. Yeah, so for each, what makes a smaller standard error? Yeah, question?
Yeah, I wanted to know the sample size.
The sample size? N. For no reason whatsoever. Just there's your mnemonic, right? Sample size is denoted by N for no reason. Because S was taken, I guess. I don't know. And SS is also something else, so they couldn't have that one. That's sum of squares. So, yeah, that's why we have to go to other alphabets, because you run out of letters real quick in trying to abbreviate things. So, yes, it is standard deviation over square root of N. So then if we want a smaller standard error, meaning more precision, do we want bigger N or littler N? Bigger. And if we want more precision, do we want big variance or little variance? Little. There you go. Good. What's the difference between a standard deviation for a sample and the standard error of the mean for a sample? This is a tricky one.
Isn't like the standard deviation only for one sample, but the standard error is like how that sample compares to a bunch of the same sample?
Exactly. So, well done. Say that again and louder.
So the standard deviation is just applying to one sample, whereas the standard error of the mean is comparing one sample to a bunch of different samples. multiples of that sample.
Comparing the sample mean
Yeah.
to other samples' sample means. Yeah, so I can give you like a real world analogy here. So my trusty Diet Mountain Dew can, right? According to this can, I have 12 fluid ounces of teaching power. Okay? Now, do you think it's exactly 12?
No.
Probably a little bit of margin of error, right? So let's say that I'm a quantitative scientist. I decide to measure this, and I find out there's only 11. I've been cheated out of an ounce of caffeine. This is a problem. Now, is it an anomaly, or is it systematically they are overselling the size of their cans? How would I find out?
Test the cans.
Test a
More
bunch of cans.
right? So I say I got a 12-pack, right? And it ends up that, let's say the mean is 11.7 ounces or something. Well, I also want to know what's the variability around that mean, right? Standard deviation, how far off? So let's say that I found out it was something like 0.2. So now I can describe my own sample, but that's not good enough. So it looks like I'm off. What do I need to do? Go get more 12-packs, right? And what I can expect to happen across the 12 packs is given by the standard error of the mean. So let's say that I have my 12-pack, there's my sample size. According to this, the standard error of the mean would be my standard deviation divided by square root, since I am from the Midwest, like that, 0.05. So what we did last time, before I started running over class, by the way, you guys, you're my clock keepers, okay? 1:45 is when we're done, right? I'm gonna learn that someday. Standard error of the mean is 0.05. So that describes how far off on average you would expect these sample means to be across 12 packs.
So you don't have to test more 12 packs, you can just use the thing?
Yep.
The thing, that's a formula?
Yeah. If you believe in the central limit theorem, and you believe that these sample means are distributed normally, then you can use one sample's variation as an approximation for how far off all the other sample means would be.
So to go further, so then let's say I get another 12 pack. We're talking in, beverages, so I can definitely do that. Okay, so I go get another 12 pack, and so then my 0.05 is so that I'm saying each can will have a 0.05.
Not the
Nope.
cans. Not the cans.
The 12 pack.
Yeah, this is a summary of one set of 12 cans.
Yes.
The 0.05 refers to how far off this one number is from the population mean. How far your sample means the mean of the 12.
So one more time.
Okay, so let me put some labels in here that'll help keep this true. Sample mean, one sample mean, sample standard deviation, sample size. This thing, standard error of the mean. So the idea is that there's two levels of abstraction here. These two columns here are summarizing one 12-pack in my example here. But then we also want to try and make a prediction. If I went through all the 12 packs in Hy-Vee, like both of them, because Hy-Vee never has diet soda, I don't know what the deal is. You have to hunt down all the area Hy-Vees to seriously. So yeah, I'll take all 3 12-packs. I hit the jackpot one day and I take them all home. And I test them all, right? This number right here is describing how far off on average the sample means would be from each other across the 12 packs.
So the measurement of D is not fluid ounces anymore.
Nope, it's describing variability of the means across the 12 cans. It's it's describing the 12 pack, whereas A and B here are describing the cans.
Gotcha.
So yeah, but we never, this is the thing about statistics, right? We never do the same study over and over and over and over again, right? Because that's not novel. That's not a novel enough contribution to the literature to be published in my favorite journal. But then there's also a replication crisis. So even though we don't have multiple 12 packs here, we're trying to use our one 12 pack to predict what would happen across other 12 packs.
So this is why we have statistics.
Yeah,
But, so we don't have to look at every single 12 pack to find the answer.
basically yes. We're making an educated guess.
Right, things are coming together.
Yeah. So you told me earlier, right, that these two things determine the standard error of the mean. What if I use a 24 pack instead? I got to go all the way to super target for that. 24 pack? Now, because it's based on more cans, right? So it should be more trustworthy. Or I go to Sam's Club, where they have 36 packs, although they don't sell Diet Mountain Dew. Even further. What? Or yeah, sorry. It's Sam's Club is my generic name for all big box stores. I know it's Costco here, and I have a proud Costco membership. My son Huey, he just calls it the big store. And here are we going to the big store where we park inside? Which, what? I've never seen that, but it's quite amazing. So what else goes into it? Variability, right? What if there was more noise in the 112 pack or 24 pack that I sampled? Let's say that the average distance from the sample mean to each individual can was 0.4 instead. Watch what happens to my standard error of the mean. Bigger. Because if it's a really noisy set of 24 cans, that makes me less able to predict what would happen across more 24 packs. So the window gets wider. And the thing that we did last time was form a confidence interval, right? Remember this? To try and quantify what is the likely window here. So the confidence interval formula, it's the middle, so equals here, the middle, plus or minus, right? So let's do the minus side. I need the standard error, right here, times what? It's a letter, not a number. It's an alphabet letter. Sorry, what is it, our alphabet called? If it's not Greek or Latin, what is ours called? Roman?
Are we wrong?
English?
The English?
I'll go with English, because I know the Spanish alphabet. They have things like Elye and Enye, right, that we don't get. So yeah, I'll just go English alphabet. It's a letter. What do you think?
Z, T.
Yeah, either of those. So yeah, what's the difference?
We don't really care about Z anymore?
Correct. But why is that?
Because we're going to be dealing in smaller samples.
Z is if you had everybody in the whole freaking world. That's the distribution. We don't get that. So T corrects for how many people you actually have. So we have a T critical value that corresponds to how confident we want to be. And so you can ask your program 90%, 95%, 99%. 1.96 is the critical value for T at sort of infinity. So that becomes Z. That's a 95%. So we'll do that there. And we'll do it again. So we'll do the upper limit here, sample mean, plus standard error, times 1.96. So that's the interval that we would expect if we got all the 24 packs in the world, 95% of the time. This would be the interval that contains my population mean.
So you're getting cheated.
I'm getting cheated, according to these data that I totally just made up. But if their factory actually was pretty precise, and on average they allowed a discrepancy of 0.1, what do you think is going to happen to my interval? narrower. And if it was actually 11.9, yeah, now it's like,
Close.
yeah.
But it's never 12.
Well, it would be if I did this. So this would be like if you're at the Pepsi bottling company, right, and you're measuring these things, like this would, you have to decide what an acceptable range around 12 is to still be able to say 12. Because in reality, it's 12-ish, right? It's always ish. The question is how much ish you're willing to say before you get caught cheating out of Mountain Dew. You with me?
Yeah.
Cool. Cheers to that. Let's all take a moment here.
I've had to question everything else in my life, and now I have to question numbers.
Yeah.
Like, thanks a lot, Lisa.
I'm sorry.
There's just nothing concrete anymore.
I know. I feel your pain. I do. Speaking of not concrete, things you can do to variables to change sort of what they mean. What's the difference between a linear transformation and a nonlinear?
Linear is like the shift, and nonlinear, you don't change them all the same.
Correct. Linear is a shift. The relative distances are changed evenly across everybody, whereas nonlinear, it's like there's a stretching or a shrinking that happens. So commonly in statistics, we'll use nonlinear transformations that are designed to solve boundary problems. So for instance, the log. In advanced models, when you're predicting counts, what's the lowest count you can have?
0.
0, right? You can't have like negative numbers of cigarettes smoked each day or something like that, or negative numbers of days in the hospital. So when you're building models to try and predict how many cigarettes someone's going to smoke, the model has to understand that you can't go past 0. There's a wall there. So what one can do is take the natural log of the count and predict that. Because the log can go on forever to negative infinity. But when you back translate that into the original count, that's called an inverse link. For those of you who need to know these words, you can think of it as unlog or exponentiate otherwise. Then the actual predicted count stays within the boundary. So it's these sorts of things are used in statistics to make predictions that can keep going on and on forever and ever in both directions, but yet when it comes back to the scale of the original variable, it keeps it in the range it's supposed to be. So we won't see too much of that until we get into models, but that's just something that comes up because oftentimes you'll see z-scored versions of variables or standard score versions of variables. That's why. So for instance, you guys ever give like standardized tests to children, like the PPBT, or you're giggling? You know, you don't. It's like, no, I don't believe in tests, right? Or like the Iowa test of basic skills or things like that. Like you're supposed to not have your scores grow, right? Like everything is normed relative to some standard because what they do is they re-norm every age. So if you are progressing at an average trajectory relative to your age similar peers, like you should get 100 every single time. The only way that happens is by changing the metric of the variable into a new one with a different mean and standard deviation at each age so that everything stays at 100. So transformations are used to help make sense of variables that have unfamiliar metrics. Nonlinear transformations are used to help solve boundary problems in prediction. So. And that's it. So, how are we doing? Good? All right. Then let me think about where we left off last time. This PC, that PC. It tells me where I left off, but that doesn't mean we need to start there. So yeah, I think we did a good job of reviewing. I'll show you the T versus Z thing. Here's a picture, just to remind you. Do you remember how T was discovered as a distribution?
Is it beer?
Beer.
Yeah.
Yes, Guinness. Yep. Because he was testing samples of hops and declaring that some of them were too far out of range, but when they were tested more extensively, it turned out they were fine. Because he was using this as a cutoff for what too far out of range was, but in smaller samples, it actually needs to be further over to capture the same width of confidence, or unconfidence as it were. All right, so we started looking at, I think, an example. So we can start there again. So I have example 3. So from now on, we're not going to run SAS in class because that's just a disaster waiting to happen. When people's laptops either break or lag or decide to update in the middle of, class, which has happened to me actually more times than I would like. So what I'm going to do is you can get the original files for all of my examples on the course website. So let me get back to that. So the files that I'm referring to are here, example 3. This is the handout that I'm going over, and then this is the SAS and Stata files. Once you download them, here is example 3. So what I've given you is a Stata version of a data set, because Stata data sets can be read into SAS but not vice versa. The output from SAS, the output from Stata, and the syntax in both programs. So if you want to run these things and see what happens, or you can just look at the output of what happens, everything is there. But what I have done is take the relevant parts of the syntax and paste them in so that we can say, like, this is, for instance, this is what you need if you want to import. Here's the code. And there's nothing different about the code other than that putting it in a handout allows me to put notes in here more easily because it's Word rather than some kind of impoverished text editor. So file save then. In your case, you will start with H, right? That's the special H place that we learned about today. The data set is called GSS subsample. So since I'm wanting to show some pictures, I selected 100 cases out of that bigger data set. That way it's easier to see. It's going to the temporary work directory, and it's called GSS subsample. If you're doing Stata version, it's the same principle, just slightly different words to accomplish the same thing. So at this point, what you would have is a data set active in memory that you can then either do things to or ask things of. So showing you what linear and nonlinear transformations do, just sort of a pedagogical thing here. We're dealing with the quantitative variable family income. I took the original variable, which is called fam inc, and divided it by 1,000 to rescale it. So that's a linear transformation. I also created a logged version as a nonlinear transformation, and I made a z-scored version. So I made a copy of it and then ran proc standard. In Stata, you can do so directly with the std function. There it is. Yep. And here's the descriptive statistics. So on average, it looks like people in this subsample had a family income of $39,000 and some change, or $39 in thousands, or exactly 0 with the standard deviation of exactly 1 in the z-score. Coincidence or not? No, that's what z-score means. It creates a new metric in which the mean is 0 and standard deviation is 1. And so we have, yeah.
Sorry, I have
Sure.
a question, if that's okay, for the
Please.
proc means. So I'm struggling, so I've got proc means, and it comes up like that, and that's very nice. And then I want to add like median and Q1 and Q2.
Ah.
But when I add that, then it just runs that, it doesn't give me this. And so what do I write there to also get that stuff?
You have to write all of this too.
Oh, you have to do it every time.
So yeah, it's funny.
Okay,
If
so I
you
thought
don't
I
write
was-
anything, this is what you get.
Yeah.
If you decide you want to add some things, it only gives you those things.
Yes.
So you have to write all of this in your list.
Oh, okay. Got it.
And it's
Cool.
N, the word mean, this is this, and then these two words. It's either these words or min and max. I can't remember off the top of my head.
Thank you.
Yeah, you gotta write all of it. Otherwise, if you want all of that information, proc univariate gives you a lot more by default. It gives you all the quantiles and things. It's just not a nice, friendly little table like this. So this, like no print, is just me turning all that extra stuff off that I didn't want. And then, because all I wanted were the pictures. So I think this is the point where we got a little past this part, but one of these things is not like the other, right? Natural log is the one that's different. it takes the bottom section of family income and spreads it out, and it takes the top section and makes it closer to the rest. So it's a stretching and shrinking. All right, there's the Stata version. And I think this is where we got off, and then you're like, hey, class is over? Why you, or I'll do a Huey impression. When he was 2, he'd say, Mommy, why you are talking? That was at dinner time when I dared to have a conversation with my spouse when he was sitting there. Mommy, why you are talking? And when he was 3, it was, why you are talking about? I'm like, oh, well, that's a much nicer question. If that's what you meant, I'll be happy to explain. I was talking about how lucky I am to stand up here and talk about numbers all day long, right? Because actually that's probably what we were talking about, because my spouse is in the same business, so it's like shop talk, 24/7. But I digress. So we were here, right, I think? So this is getting the software to do what we just did off the top of our heads about Mountain Dew cans with real data. So I asked it to describe the variable years of education, and this is what it came up with. So on average in this subsample, it gave me a mean of 13.8. That's a sample mean, so we would call that either Y bar or the letter M. Standard deviation, so how far off, on average within this sample of 100 people, the average offness from the mean is about $3,000. So we can use that information right there, along with sample size, to get the standard error. So this is talking about, like, if I had taken this big data set and repeatedly drawn samples of 100 people, like lots and lots of samples, like lots of 24 packs, on average, this sample mean would be off from each other by the standard error. So this is a higher level of abstraction. The maximum is $200,000, the minimum is $4,000. My guess is that this is an artificial maximum because it looks like they truncated the distribution at some point. But we can use this mean and this standard error to make a confidence limit. So it's plus or minus, it's the mean is the middle, plus or minus standard error of the mean times whatever critical value you want. So if it's 95% confident, then that's using the critical value that gives you only 5% else. And we also have a confidence interval for the standard deviation. By the way, this is another thing that drives me nuts. This is CL, this means confidence limit. That's the same thing as CI for confidence interval. Sometimes it's CI and sometimes it's CL. But I asked for 95% confidence by selecting this right here, these two things. Alpha is unconfidence. Do you remember, let me find a picture here. This one, remember this picture? You may not, so I'll show it again. So we're trying to quantify how much variation is sort of expected versus aberrant. Expected is like confidence. Aberrance is 1 minus confidence, or alpha. So if I have a critical value of, this is minus 2.58 here, this is in Z land, or infinite T, then only 1% of the time would you expect to find a sample mean that discrepant if the true mean were here. So it's 1%, 1% here or here, 5% here or here. So two sides means that you are willing to accept the possibility that your sample estimate is either too high or too low. That's going to be the gospel as far as I'm concerned. Only in situations where one side is impossible, or in very specific applications in like clinical trials where you're trying to compare like a drug and you don't care if it's just as good at, you only want to know if it's better. Like there's just very few circumstances in which you can justify one side. So we're going with two sides. So our critical number 1.96 means that 95% of the time you'd be here and 5% you'd be out here. So alpha is aberrant. There's a mnemonic for you.
Yeah, what's the word? A-B-E-R?
A, B, I think there's an H. Can anyone spell aberrant off the top of their head? Let's find out. I'll ask the Google. Aberrant. Abercrombie. No. Aberrant. There's no H. Aberrant. There we go. Yep. Alpha is aberrant. It's also sometimes known as the p-value because it's the probability of the aberrance that we're interested in. So given this one sample, we are trying to extrapolate what would happen if we had more samples. And this is the interval in which the population mean should be found 95% of the time, if this sample is a good reflection of all the possible samples. So if I had a hypothesis, for instance, HO, what does that mean? Do you remember? Have we talked about that yet? Actually, I don't think we have. We'll get to it. It means null hypothesis.
Oh.
Yeah, you've seen this before, right? That is, by the way, as not 0, I think. Is that 0 or is that, I think that is the letter O. So if you type 0, it may yell at you. Just as an example, I put in a null hypothesis that I thought the sample mean should be 12. 12 years of education. Turns off, according to this result, I am way off. So how far off am I? Well, the t-value that goes with a sample mean of 13.8 is 5.65. It's positive because my mean is way higher than the 12 I thought it would be. So here's my picture. We're like way out in Redland here. That's where we are. So if the true mean education was 12 and we got a 13.7, that's way out here. So there's not a lot of times where we would see a sample mean of 13.8 if the population mean were 12. So it's in aberrant land. I think the H is abhorrent. I think that's where I was coming from with that.
Yes.
Slightly
That's what I was
different.
thinking.
So, well, either one of those works, right? It's aberrant and abhorrent.
I was gonna make the joke, that's why I think it probably,
Yeah.
like, that's important.
Yeah, so it's aberrant and abhorrent if you want to sound smart. It's shitty if you're talking the rest of the time. All right, here we go. So how aberrant is it? Well, it's less than 0.01% of the time. So by the way, sometimes you will see p-values reported as equal to 0. It's never 0. It's just that it's 0 to the number of decimal places that it chose to report. Okay, how are we doing? All right, so Stata, let me see if I can get the code here. Some of you are pledging allegiance to Stata, right? Urela, you are, and your EPLS, and so Terry has to pledge allegiance.
I'm using Zask.
Apparently I have no choice.
Yep. Well, the good news is that once you learn one, it's easy to learn the other. But there's just little idiosyncrasies across programs, right? So I'm doing the exact same thing, and honestly, I had never done this before, so I asked the Google. And I said, Stata one sample t-test, because I know that's what this is called. And so I found the manual for it. So it's t-test, proc t-test, that much is the same. Education equal 12 is how you tell it what your null hypothesis is. Level is the opposite of alpha. So alpha is the aberrant, level is the expected. The confidence level is referring to the middle. If you want the confidence interval for the variance, you have to ask for that as a separate command. But then everything matches exactly. So it gives you the p-value for both the two-tailed test, which is the middle here. The exclamation point means not. Exclamation equal means not equal. So it's not making a statement about whether it should be bigger or smaller, just not 12. Whereas the probability that the mean is less than 12 there's basically no chance that it could be because it's higher. And this is the other version of the tail. And because I'm nice and I want you guys to like me, and I can't afford to bring you pizza every time, I compromised, and here are some words. So what we just did, this is what you would put in a manuscript describing it. So I want to point out a couple of formatting things, because when I review papers and I see sloppy formatting, it makes me like everything else seems suspect too. You know, like if you can't even get your italics right, how am I supposed to trust your study, right? So the extent of unexpected deviation of our sample mean, so here's my friend M, italics, SD, SE for sample mean, and I gave the confidence interval for the sample mean. From the hypothesized value of 12 years was examined using a one sample t-test with a two-tailed alpha level of 0.05. And so here's my t. The common way to report this, in any statistic, you'll see lots of instances, is whatever the test statistic is. So this will be either F, T, Z, or chi-square. In parentheses is degrees of freedom. Do you remember that from last time? Degrees of freedom starts with your sample size. It's 100. And it penalizes you for how many things you had to estimate in order to answer your question. At this point, we've only estimated one mean. So we got 99 left. Now I got 99 problems, but the mean ain't one of them. Oh! That was a good one. So t-value, comma, p italics less than 0.001. So in English, right, because this is the stat part. Like, do people like my husband who would look through books and they're like, words, words, words. Like, this is sufficient. To everyone else, it's insufficient. So always, 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 comma, translation into English. Indicating that is my favorite. Such that is another. The sample mean of 13.1 was significantly larger. So why do I say significant? Because this t-value exceeds the random. By the way, your choices are significant or not significant. If you say insignificant, someone will laugh at you. Because that is a value judgment, not a numbers judgment. So it's either significant or not. You can have a significant finding that is insignificant to someone, right? The rest of this that's in parentheses is really just like belaboring the point. I probably wouldn't put that in a paper, but I wanted to give it to you in words. The sample mean of 13.81 would be expected less than 0.01% of the time if the population mean were 12. And then a note about significant digits, because we have values here that are already past the decimal. 2 significant digits I decided was enough. You just want to pick one number usually and stick with it. Okay. Questions? Is it 1:45 yet? Okay, not yet. Okay, good. Because I'm on a roll. How about if I have a binary variable? Same idea. The mean of a binary variable is the proportion of either 1 or 0. I say that because it turns out that SAS and Stata have different defaults as to which one it counts. Just for shits and giggles, right? Mm-hmm. This is the job security portion of the program, right? If you learn these ins and outs, someone will pay you to not have to learn it for themselves. So proc-freq is how we deal with frequencies for categorical variables, such as a proportion of men versus women here. I am asking it to find a confidence limit around the proportion as using 95% confidence, and testing a null hypothesis that the proportion of men versus women should be 0.5. That's what it's supposed to be in the population, right? So we have 61 men and 39 women in this sample. That's a proportion of men of 61. The way this is coded is that men are 0 and women are 1. So it's testing the proportion of men. I found that out just building this example. I did not know that. ASE is the asymptotic standard error, and it uses that to form a confidence limit. The trick with confidence limits and standard errors in binary data is that it's bounded. right? Like if I have a proportion of ones of 0.99 and I have a standard error around that of like 0.02, you know that you can't have a proportion go over 1. So you can't make a regular two-sided interval if you have proportions that are close to the edges. And there's like 8,000 ways to solve that problem. This is one of them that shows up by default. So if reviewer 3 ever asks about this, you can report the exact test instead. The conclusion is pretty much the same. So in this case, we do have a z. So z is back for like 1 minute. The difference is because we don't have variance as part of our output here, right? There's no standard deviation. Do you know why that is?
Because you're either, or I guess maybe not.
Yeah, you know the variability. So if I have 61% men, and I know this is a binary variable, it's 39% something else. So that mean dictates how much variability there is. So we don't have to try and approximate it with the sample, which means that we can use z instead of t. So in reporting this, I switch. The format is exactly the same, but instead of a t with the degrees of freedom, it's a z, which assumes infinite degrees of freedom. So proportions are one sample z tests instead.
I have a quick question.
Yeah.
So in the categorical variable, whatever you want to say, above, so male and female is not binary anymore, right? So how would you do that so now let's say in my survey I have you identify as male, you identify as female, prefer not to say, or and then or like a whole laundry list of different. So those you obviously wouldn't run the test the same way.
Correct.
You still do a frequency.
You can do a frequencies, and in fact, in your first homework, I adapted this. There is a non-binary third choice in one of your categorical variables for gender. The question would be, how do you approach a hypothesis test about what a proportion should be? And you would have to decide whether or not you want to say, like, out of everyone, like I want to know what the proportion is of this group relative to some expected value, or whether you want to limit your groups to a subset.
Yeah. Okay.
So either way, I think to do this, you would have to recode into the group that is your target, and then everybody else is not that. Or you take my next class, and I'll teach you how to do it in a model.
See you there.
Just saying. All right, so yeah, Stata does the proportion of females by default. In this case, it's the same idea because it's testing against 50-50, but you could imagine it would make a difference. So what if you wanted to get the other one? So those of you who are only pledging allegiance to SAS, what if you saw this and you were like, I wanted the proportion of females, not males? Well, easiest way to solve that problem is to recode the data. So here's an example of how to do that. In SAS, because you can have multiple data sets open at the same time, the data set you want to do something to has to be here, data, data set, set, data set. Otherwise it will yell at you. And I am making first a new variable that I am calling male. So it is a convention that when you have a variable like this that's a 0, 1, the name of the variable goes with the 1 group, because it's like, what is the effect of being the 1? So it's named female. So I'm swapping it, and I'm making men the 1. So I'm starting out with men equals dot. Any guesses as to why or what that's doing? And feel free to read from the screen too. Let's see, Michael, you nodded.
But
I swear you did. Maybe Jeff nodded. I swear someone nodded over here. So don't go on me. This initializes it to an empty value. Then, if female is 0, I want to take my new variable and make it 1. If female was 1, I want to make it 0. That way, if a female was missing, I'm not accidentally assigning a value to this that it shouldn't be there. Like the default is missing. If we meet certain characteristics, then it changes off of that default of missing. So then I use that new variable And it's still doing the proportion of zeros, but now zeros is the group that I want it to be. And the result is exactly the same, just in the opposite direction. So the z is minus 2.2 because 39 is less than 50 that we expect, whereas up above, 61 was more than the 50 we expect, and so the z was positive. So t's and z's have negatives or positives that go with them. That implies whether or not the result is above or below what you expected. There. Okay. And in this case, a note about writing this up. So I'm giving the coding of the variable so that people know what 0 and 1 means. So the mean of 0.6 only has meaning if you know who's the 0 and who's the 1. So that's imperative to give that to them explicitly. I don't have a standard deviation to report, but I do have a standard error. You could report the standard deviation, but it's not typically done. Note that because all of the values that are in this paragraph are below 1, proportions and things like that, I chose to have 3 significant digits to help keep them separate. So here's my z value, my p value, indicating that the sample proportion of males of 0.6 was significantly larger than the hypothesized proportion of 0.0. So same formula. Say, what are you doing? What happened in stat E's, comma, English? All right. So these are examples of univariate hypothesis tests. Whether or not some number corresponds to what is expected in the population. I have done maybe 1 or 2 of these in my lifetime. What is way more common is bivariate. So that's what we're doing next. So you know the word bivariate, right? 2. So associations between variables, whether or not variables are related. And there are 2 main kinds of variables that we need to worry about, categorical and quantitative. And how you determine if they are related depends on what combination you have. Categorical is one, quant is another, and then a mixture. So that's what the next part of this is. We'll have to go back to the slides and talk about bivariate association. So let me see how much of this is going to be familiar and thus how in-depth we need to go. How many of you have seen Pearson's correlation before? Half, all right. Chi-square, Pearson's chi-square. Oh, more people with that one. Okay, cool. Yeah, Pearson was a really busy dude, and he liked to name everything after himself.
Now he's really rich.
Yeah, well, he's also really dead, so. Yeah, that's the irony, is that the stuff that I'm teaching you is like, this is literally from like the 1800s, like when all this was made. Now just think about that for a minute. Like, how would you feel if you went to a specialist, right, for a surgery, and they were trained in 1900s technology? Didn't that give you pause?
Bloodletting.
Exactly. Yeah, here's some leeches. You have my cell phone if you need anything, right? Yeah, so this is a place to start, but there's a lot more. These things are still useful, but they don't answer a lot of research questions beyond just sort of, is this related to that? So keep that in mind, that this is not exactly state-of-the-art stuff, but people will expect you to know what this is. So it's a good place to start. And I think since we don't want to start a new topic with 5 minutes left, we'll be done for today. How's that sound? Okay, so I have, my next class doesn't get here until 2, so if anybody wants to stay and fight with SAS, I can help with that. Otherwise, I will see you Thursday. Or in office hours, one of the two.